All right, so earlier on I had mentioned something, a relationship, where we said voltage is directly proportional to current flowing. So Nathan had a question, and unfortunately we were discussing it off camera, so I thought I should bring it to the camera. Now, we said voltage is like the potential energy you're providing to cause current to flow in a conductor. And as we said earlier on, when you increase voltage, even current flowing through the conductor will increase, just because you've provided more energy to push the electrons through the conductor, to allow it to flow through the conductor. That's why there's a direct proportionality. Voltage increases, current flowing will increase. Of course, assuming the resistance of this wire is kept constant. Now, the point of contention that he had was why there is an inverse proportionality between current and resistance, in the sense that when you increase resistance, the amount of current flowing is greatly reduced. Because what we were saying is, we earlier on mentioned that resistance is the opposition to flow of electrons. So he was wondering why, when the resistance increases, the current flowing reduces. Now, assuming we've kept the voltage constant, that's the energy we are providing to be the same. Now, I gave him an analogy of consider that wire like an opening, yeah, or an entrance. Now, then let us assume it's a circular entrance to a location this side, and we represent current with people. So if we have a lot of people here trying to access that entrance, which for some reason is restricted, that means okay, anyway, so if we wanted to prevent people from accessing this thing, we would provide security guards, right? Now, if you have one security guard, a certain number of people will pass. When we increase the number of security guards to stop people from passing, that means fewer people will make it to the other end. Yeah. So assuming there's no security personnel, all of these people would end up the other side. If I put one security personnel, one or two people may be able to run past him and end up this side. If we fill this entrance with security personnel filling up every space, you'll almost reach a point where almost none makes it through the other side. So look at resistance as security personnel limiting people from going through. So and these people are like the electrons trying to end up to the other side, and this entrance is like, this access is like our conductor or wire. So anyway, that's just to shed some light on why current is inversely proportional to resistance, in that when resistance increases, when the number of people stopping people from passing through there increases, the current reduces. That means fewer people are able to pass through. I think that sort of sheds some light. Anyway, see you in the next video.